A road roller can weigh more than 20 tons, yet instead of destroying the road beneath it, it actually makes it stronger. That sounds impossible, doesn't it? The secret isn't just its massive weight. It's hidden inside the giant steel drum. Today, we'll uncover the fascinating engineering that allows this machine to build roads designed to last for decades. Most people believe a road roller has one simple job: crush the ground. Heavy machine, heavy drum, drive back and forth, and the job is done. But that idea is completely wrong. If road construction actually worked that way, roads would fail much faster. The real goal isn't to crush the material, it's to rearrange it. Imagine pouring sand into a bucket. At first, the bucket appears full, but if you shake it, the sand settles lower without a single grain being crushed. The grains simply move closer together, leaving fewer empty spaces between them. That's exactly what engineers want to achieve beneath every road. Fresh soil contains countless tiny air pockets between individual particles. Those invisible gaps are weak points. As vehicles repeatedly drive over them, the particles shift, the surface settles, cracks begin to form, and eventually potholes appear. Instead of smashing the ground flat, a road roller removes those hidden air spaces until the material becomes dense, stable, and capable of supporting enormous loads. But here's where things become even more interesting. Weight alone isn't enough to make that happen. From the outside, the drum looks like nothing more than a giant cylinder of steel. Most people assume it simply rolls over the ground using its tremendous weight. But hidden inside many modern road rollers is something far more sophisticated. Inside the drum is a rotating, eccentric weight. If you've ever watched a washing machine during an unbalanced spin cycle, you've already seen the same principle at work. When something heavy spins off-center, it creates powerful vibrations. Road rollers intentionally generate those vibrations thousands of times every minute. Instead of simply pressing downward, the drum sends controlled vibrations deep into the material below. Those vibrations gently shake individual particles until they naturally settle into tighter positions. It's much like shaking a box filled with marbles. At first, the marbles are randomly arranged. After a few shakes, they automatically settle into a tighter, more compact arrangement. The volume decreases, the density increases, and the entire structure becomes stronger. That's why vibration is often far more important than weight itself. Surprisingly, however, engineers don't always want maximum vibration. Sometimes they intentionally reduce it. It seems logical to assume that more weight and stronger vibration would always produce a better road. But engineering rarely works that way. Different materials respond differently to compaction. Gravel behaves differently from sand, and clay reacts differently from both. Applying excessive vibration to the wrong material can actually reduce the quality of the finished surface instead of improving it. There's another challenge as well. Construction doesn't always happen in wide open spaces. Roads are often built near homes, offices, bridges, and other sensitive structures. Strong vibrations don't simply disappear into the ground. They can travel outward. Excessive vibration has the potential to affect nearby buildings, which is why operators carefully adjust their machines instead of using maximum settings all the time. Many modern rollers even include oscillation systems that compact materials using a different type of motion. These systems reduce unwanted ground vibration while still achieving excellent compaction. In other words, the smartest road roller isn't necessarily the most powerful one. It's the one that applies exactly the right amount of energy. But that raises another fascinating question. How does the machine know when enough compaction has been achieved? This is where road rollers become surprisingly intelligent. Modern machines don't simply vibrate, they constantly measure what's happening beneath them. As the drum moves across the surface, Sensors monitor how the material responds. If the ground remains loose, the system detects it. As the soil becomes denser and stronger, the machine recognizes that change as well. Some advanced rollers can automatically adjust vibration intensity based on these measurements, ensuring efficient compaction without unnecessary passes. That means the operator isn't relying entirely on experience anymore. The machine is collecting information every second and responding to changing conditions. Think about that for a moment. A construction vehicle weighing more than 20 tons is continuously listening to the ground beneath it. Rather than relying on brute force alone, it uses feedback to decide exactly how much energy should be applied. Every pass provides new information, and every vibration helps create a stronger foundation. But if every road roller performs the same basic task, why do they come in so many different designs? If you've ever watched a construction site carefully, you've probably noticed that not all road rollers look alike. Some have perfectly smooth steel drums, while others use multiple rubber tires. Some even have drums covered with raised metal pads that resemble giant feet. The reason is simple. Every material requires a different compaction method. Smooth drum rollers are ideal for asphalt and granular materials because they create an even surface. Pad foot rollers penetrate deeper into cohesive soils like clay, allowing lower layers to be compacted more effectively. Pneumatic rollers use several heavy tires to apply pressure across a wider area, making them especially useful during certain stages of asphalt construction. Rather than relying on one machine for every task, engineers select different rollers depending on the material and the stage of construction. Building a durable road isn't about using the heaviest machine available. It's about choosing the right tool for the right job. So why doesn't a 20-ton road roller destroy the road beneath it? Because the road isn't surviving in spite of the roller. It's becoming stronger because of it. The machine isn't designed to crush the surface. Instead, it's engineered to transfer energy into the material in a carefully controlled way. Weight provides pressure. The drum creates contact. Internal vibration rearranges particles. Sensors monitor progress. Operators adjust settings according to the material being compacted. Every pass is calculated. Too little compaction leaves weak spots that eventually become cracks and potholes. Too much compaction can also create problems if the wrong settings are used. The real engineering achievement isn't simply building a machine that weighs 20 tons. It's learning exactly how to use those 20 tons with remarkable precision. The next time you drive past a road construction site, take another look at that slow-moving machine. What appears to be nothing more than a giant steel cylinder is actually performing one of the most important tasks in civil engineering. Every vibration removes hidden weaknesses. Every pass increases the strength of the ground beneath it. Every adjustment helps create roads that can withstand years of traffic and changing weather conditions. A road roller isn't just another heavy machine. It's a carefully engineered system that combines physics, precision, and intelligent technology to build the roads we depend on every day. And that's the hidden science behind one of the most overlooked machines on any construction site.